these are the solutions for your Unit 1 review to prepare for the upcoming test on rationals and integers. While you're watching the video, you need to use a grading pen to correct any problem or work you missed. So in addition to making sure your answers are correct, you need to make sure that you also have the correct steps showing how to get the answer. Okay, number 1, a diver dove off a cliff to a depth of 18 feet, and then he went up 9 feet. So here's the cliff, here's the water. He dove off to negative 18, and then he went up 9 feet, which would put him still 9 feet below the water. Two different expressions to represent the situation. You could start by doing negative 18 plus 9. That's one option. Another way that you could write that is negative 18 minus negative 9. So those are just two expressions that are equivalent to each other. A third expression could be 9 minus 18. Okay, any of those that you use will give you a final depth of negative 9 feet. You do need to make sure that you have units so that you don't lose half of a point on any questions that require units. Okay, and explaining your answer, same thing that I just explained. You could use a picture and describe what's happening in words to explain. All right, second one, this is where we're going to start working some problems. So the first one, we have two mixed numbers. Our first step is to change them into improper fractions. So I'm going to multiply 8 times 7 and then add 3. So 8 times 7 is 56, plus 3 would be 59, and the first fraction is negative. And then we're going to add 6 times 4 is 24, plus 1 is 25, so we get 25 fourths. Okay, so step 1, change mixed numbers into improper fractions. Now we need to get common denominators. So 8 is a common multiple. Okay, the first fraction can just stay negative 59/8. The second one, I multiplied 4 times 2. So I'm going to do the same thing to 25 to get the numerator. So 25 times 2 is 50. So negative 59/8 plus 58. 1 is positive, 1 is negative, which means I'm going to subtract the digits. But since I have 59 negatives and only 50 positives, my answer will be negative. So that should be negative 9. Okay, so negative 9/8. And then the final step is to change that back into a mixed number. 8 goes into 9 one time with 1 out of 8 left over, and that'll still be negative. So negative 1 and 1/8 for part A. All right, part B, I need to still follow order of operations. So I'm going to do the parentheses first. Negative 5 plus 1 and 25/100. I have different signs, so I'm going to subtract with the larger number on top, or the number with the greater absolute value on top. That way, if you need to borrow, you can. Okay, 9 minus 2 is 7, 4 minus 1 is 3, and the decimal comes straight down. There was more negative than positive, so that would be negative 3.75, or negative 3 and 75/100. Next, I'm going to bring everything else straight down. Okay, now when deciding between adding and multiplying, I need to multiply for the next step. So negative 3 and 75/100 multiplied by 3. So 3 times 5 is 15, 3 times 7 is 21, plus 1 is 22, 3 times 3 is 9, plus 2 is 11. Okay, we're going to count over 2 places. It's over a total of 2 places to put the decimal. And a negative multiplied by a positive is a negative. So we get negative 11 and 25/100. And then bring everything else down. Negative 2 and 5/10 minus 11 and 25 hundredths. Okay, next, change it to an addition problem. Negative 2 and 5/10 plus negative 11 and 25 hundredths. This time, both of the signs are the same, so I'm going to just end up with more negative. So a negative plus a negative is always a negative. Don't confuse this with your multiplying and dividing rules. So I'm just going to add them up, 11 and 25 hundredths plus 2 and 5/10, or 50 hundredths. And it's a negative plus a negative, so the final answer is negative. So negative 13 and 75 hundredths for part B. All right, part C, we're going to keep using add, opposite to change it to an addition problem. So we have 5 and 2/10 plus positive 1 and 6/10. If you need to, you can line up your decimals and set it up vertically. The decimal drops straight down for adding, so you get 6 and 8/10 as your answer to part C. Okay, part D, there's no symbol, so this means that we are multiplying. So we can set it up vertically. 4 and 3/10 multiplied by 5 and 2/10. So we're going to multiply just like if it was 43 times 52. 2 times 3 is 6. 2 times 4 is 8. 0 for a placeholder. 5 times 3 is 15. 5 times 4 is 20. Plus 1 is 21. Now we'll add. And now the decimal point, it's moved over one place in the first number, one place in the second number, which means I need to move it over a total of 2 digits. So 1, 2. And it was a negative multiplied by a negative, which would be a positive. Okay, if we just did an estimate, 4 times 5 is 20, so it seems reasonable that our answer would be 22 and 36 hundredths. Okay, part E, we're starting to get into some multi-step. We have 2 and 1/4 minus 8 and 5/10. You should change these either both into fractions or both into decimals. I know that 1/4 is equal to 25 100ths, and I could show that 1 out of 4. I'm doing times 25 times 25 to get 25 hundredths. So that means I can rewrite the problem as 2 and 25 hundredths as a decimal minus 8 and 5/10 all over 3, or all divided by 3. All right, we have a subtraction problem, so we can use keep, add, opposite to make it 2 and 25 hundredths plus negative 8 and 5/10. Okay, I have one of each sign, one positive, one negative, so that means I'm going to subtract with the number that is further from 0 on top and the number closest to 0 on bottom. Okay, I have more negative than positive, so the answer will end up negative. Okay, we'll need to borrow. 10 minus 5 is 5. 4 minus 2 is 2. 8 minus 2 is 6. So we get negative 6 and 25 hundredths all over 3, or all divided by 3. All right, now we'll set up the division. So 6 and 25 hundredths will go inside. 3 will go on the outside. Top dog sleeps in the doghouse, bottom dog sleeps outside. I know that I have a negative here, but I'll come back to that once I have my solution. All right, 3 can go into 6 twice. 2 times 3 is 6, so subtract. Bring down the next digit. 3 goes into 2 0 times, and my decimals are going to line up. Bring down the next digit. 3 goes into 25 8 times. Add a digit if you need to, add a 0. 3 goes into 10 3 times. So we have 3 times 3 is 9. Subtract, and now we're going to get 10 again, which means that the 3 is going to repeat. So you get 2.0833333 repeating. Okay, and then I do know that it's negative, so my final answer is negative 2.083 with a repeating bar above the 3. All right, part F, we need to change mixed numbers into improper fractions. So I'm going to do 3 times 5 to get 15, plus 2 is 17. So 3 2/5 is equal to 17/5. Divided by 10 times 2 is 20, plus 9 is 29. So negative 29 tenths. Okay, anytime you are dividing fractions, you're going to keep the first one the same and change it into a multiplication problem by multiplying by the reciprocal, which means you flip the second fraction. And it's negative, so I'm going to keep it negative. All right, so we have 2 options. We can multiply 17 times negative 10, and we can multiply 5 times 29 to get your answer. That will work. You can also simplify first to make your numbers a little bit easier to work with. So if we have the fraction negative 10/5, we could divide by 5 to get negative 2/1. So I'm going to replace negative 10/5 with negative 2/1, and that will make my multiplying much easier, because then I can do 1 times 29 and 17 times negative 2. Okay, now we'll multiply that. 17 times negative 2 is negative 34/29. Okay, 29 goes into 34 once with 5 left over. And I'm going to keep that number negative. All right, next we have a number line. You'll see 0 in the middle, and then we have 1, A, and then B on the negative side. So we know that B is a negative number. We also know that the absolute value of B is greater than the absolute value of A. All that means is B is further away from 0 than A is. Okay, so when we add these, you can kind of go one of 2 ways. You can pick some numbers and estimate what it would be to decide if it's positive or negative, or you can look at the distances from 0. Okay, since B is further from 0, that means that there are more negatives, which means your overall answer when you add a positive and a negative that is further from 0 is going to be negative. Okay, so you can use A and B, or if you want to estimate and say that maybe A is 1.5 and B is negative 3, then you could show that negative 3 plus 1.5 would be negative 1.5, which shows in symbols that it's negative. Okay, so again, 2 options. One is to use some numbers and show how it works. Kind of a more advanced answer would be to use your algebra and talk about the absolute value of B and how it compares to the absolute value of A. So use that in your explanation. You do need to put words with your explanation. All right, part B. Again, we can use algebra, or if you want to use the numbers, we could do A, which we said was about 1.5, minus negative 3. Okay, when we do that, we're going to do keep, add, opposite. So opposite of negative 3 is 3, which when you add 2 positives, you will always get a positive. Okay, and then on part C, we can plug in our numbers again. This time we could do 3 minus 1 1/2. And actually that's negative 3 minus 1 1/2. So that would be the same as negative 3 plus negative 1 1/2. anytime you add two negatives together, you're going to get more negatives. So that would be -4 and 1/2. So we would answer that B minus A would always be negative. And again, you'll use words to explain how you can tell. All right, part D. This time we are multiplying a positive times a negative, and then subtracting 1. Okay, a positive multiplied by a negative will always be negative. And if you have a negative number and subtract 1, that's the same as adding a -1. Okay, so if you have negative and you add more negative, you're still going to have a negative. Okay, and part E, that slash for the fraction A over B means A divided by B. So if we have a positive divided by a negative, we will always have a negative. And that's just one of our rules about multiplying and dividing integers. Alright, next, use a number line to demonstrate how to find the difference 3 minus 9. So we'll want to label our number line. So we've got 0, 1, 2, 3, 4, 5, 6. And then we can go the opposite way. -1, -2, -3, -4, -5, -6. Okay, you're always going to start at the first number, which is 3. And then when you are subtracting 9, you can subtract 9 or you can add -9. Either way, you're going to be moving 9 units to the left. So we'll count 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that would be the picture, and then we could write 3 minus 9 or 3 plus -9. Both are equal to -6. Right, number 5, use long division to determine if the decimal representation for 1/9 is repeating or terminating. Show your division. Okay, just like before, top dog goes in the doghouse, bottom dog has to sleep outside. Okay, 9 goes into 1 0 times, so we'll add a decimal with a 0, decimal right above. 9 goes into 10 1 time. 1 times 9 is 9. And we'll subtract to get 1. Okay, bring down another 0 to get 10. 9 goes into 10 1 time, and we're going to get the same thing over and over and over and over again. So we can put the repeating bar over. This number would be the same as just having 1 with the line over it. Either way would work. So we would say the decimal representation for 1/9 is repeating, because when I divided 1 by 9, the answer was 0.1 repeating. Alright, number 6, always, sometimes, or never. We did some of these in class on one of our problem-solving assignments. There is a hint that you can use if you would like, or you can use algebra to explain it. The hint says pick 2 positive numbers, 2 negative numbers, and then 1 of each to see what happens. So for part A, let's just pick some easy numbers. Let's say m is 2 and n is 1. Okay, so when we subtract, m minus n would be 2 minus 1, we're doing absolute value, and we're seeing, is that equal to the absolute value of 2 minus the absolute value of 1. Okay, 2 minus 1 is 1. Absolute value of 1 is still 1. Absolute value of 2 is 2. Absolute value of 1 is 1. and 2 minus 1 is 1. So that is an example of when it does work. Okay, let's try two negative numbers. So this time we'll do m is negative 2 and n is negative 1. So we'll do negative 2 minus negative 1. And see, is that equal to the absolute value of 2 minus the absolute value of 1? Okay, we're subtracting a negative, so we'll use keep, add, opposite, which would be negative 1, and the absolute value of negative 1 is 1. Absolute value of negative 2 is 2, absolute value of 1 is 1, and 2 minus 1 is also 1. So this is a second example of where it does work. Okay, now we're going to pick one of each, one positive and one negative. So let's go back to our numbers. How about if we have m equals 2 and n equals negative 1? Okay, we'll plug it in just like we did before. 2 minus negative 1. Is that equal to the absolute value of 2 minus the absolute value of negative 1? So we'll still use keep, add, opposite. And the absolute value of 3 is 3. Okay, on this side we have absolute value of 2 is 2, absolute value of negative 1 is 1, and 2 minus 1 is 1. So these are not equal. So we had two examples that worked, one that didn't. So we would say sometimes. And then for your explanation or your justification, you'd want to show all three examples, and you could say, here's an example of where it does work when we have either two positives or two negatives, and here's an example of where it doesn't work when we have one positive and one negative. So again, make sure you have words explaining the steps that we just showed. All right, part B. B plus negative b equals 0. Is that sometimes always or never true? There's only one number that we're choosing, so we'll choose a positive and a negative. So let's do it first if b is 1. Okay, 1 plus negative 1 is 0. Those are opposites, so that one would be true. Okay, if b equals negative 1, then we would have negative 1 plus negative 1, and we're deciding, is that equal to 0? Okay, negative 1 means the opposite of negative 1, which would be 1. So we have negative 1 plus 1, and that is equal to 0. So it works for a positive and it works for a negative. In your justification, you could say that anytime you add a number and an opposite, you will always get 0. So you would say always, and explain why using words and math to justify. Okay, number 7, order the values from least to greatest. So we have a number line. Let's put 0 in the middle, and then we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. Okay, we can use the number line to put these numbers on it. This first value is the absolute value of 3 2/10, which would be positive 3 2/10. So that would be right about here. So I'm going to list that. I'm still going to copy it the exact same way that it's listed, even though I already found the absolute value. Okay, 7 is right here. Negative 5 is here. Absolute value of negative 2 3/4 would be, this one in red, right about here, a little bit further over. So negative 2 3/4 absolute value, and negative 4 would be right here. Okay, I have all of my numbers, so now I'm just going to list them off in order. Okay, first is negative 5, then negative 4, then absolute value of negative 2 3/4, Next is absolute value of 3 and 2/10. And finally is 7. Right, number 8, two integers, so those are positive or negative whole numbers. We're going to call them n and p, have a product of negative 36. What is the smallest possible sum of n and p? So product, remember, means multiply. Sum means add. So one option is to make a chart and just see what are all of the factors of negative 36. We know we're going to have one positive and one negative. So we could write negative 1 times 36 would be 36. We could do negative 2 times 18, negative 3 times 12, negative 4 times 9. 5 won't work. 6 will work. We could do negative 6 times 6. Okay, then the other options are just the reverse of that. So we could do 1 times negative 36, 2 times negative 18, 3 times negative 12, 4 times negative 9, and 6 times negative 6. So in blue, I'm going to write all of your possible products. Let's pick a different color. We'll use green to represent all of the sums. So now I'm going to add them up. So if I do negative 1 plus 36, I'm going to get 35. Negative 2 plus 18 is 16. Negative 3 plus 12 is 9. Negative 4 plus 9 is 5. And negative 6 plus 6 is 0. Okay, same thing for the second set. 1 plus negative 36 is negative 35. 2 plus negative 18 is negative 16. 3 plus negative 12 is negative 9. 4 plus negative 9 is negative 5. And 6 plus negative 6 is again 0. So you'll notice that in our sum columns, when we add them, you're going to get the same numbers, just their opposites. Okay, and we are looking for the smallest possible sum. So the number that would be furthest to the left would be negative 35. So we could say that n is negative 36 and p is 1. So the negative number is negative 36, the positive number is 1. Okay, and then for explain how you found your answer, you could just say I made a list of all of the possible factors or all of the possible numbers that would multiply to negative 36. I added all of them up to see what the sums would be, and then I just picked the one that had the smallest sum. So you just put that into words for part B. All right, number 9, Amanda's checking account balance was negative $245. She deposited $60 3 times. What is her current balance? So we can either set this up as one expression and solve it start to finish, or we could show each step. Okay, let's look at both ways. If you start at negative $245, and then you deposit means you add money in, okay, and withdraw means you take money out. So she's adding in $60, and she's doing that 3 times. Okay, that's what your expression would look like. You could also start at negative 245 and start adding in $60 each time. So we're going to get closer to 0 every time. So that means that we're going to have a smaller negative. Okay, so we do 14 minus 6 is 8. Okay, so that represents 1 time. Then we could subtract 60 again to get another negative number. 5 minus 0 is 5, 8 minus 6 is 2. So after the second time, she'll only owe $125. Okay, and then after the third time, still subtracting, 12 minus 6 is 6. So this shows that she will have negative $65 in her account. Okay, the other way, we can use order of operations, so we'll do 60 times 3 first, which would be 180. Okay, and you'll notice that 60, 60, and 60 is 180, plus 245, negative 245. Okay, we have different signs. One is positive and one is negative. There's more negatives, so your answer will still be negative. Okay, and we're going to do 245 minus 180. 14 minus 8 is 6. 1 minus 1 is 0. So we still end up at negative $65. And again, make sure you have your units on there, either the word dollars or the dollar sign, to get full points. All right, you should now have a complete review so that you can study. If you study all of these problems on the test and you're on the review and you're able to do them, then you should be able to do well on the test.